Hi there, everybody, and welcome back to Business Economics. This is Professor Kern once again, and for this part of the lesson, I'm going to talk to you about how we go about calculating elasticity of demand and what we can kind of do with that kind of information. Now, as we learned in our previous lesson when we talked about supply and demand, elasticity refers to the degree to which quantity demanded will shift, given a change in price. And when we look at our classic price, quantity, demand curves, generally many of them slope downward like this because of the law of demand, right? So at higher prices, the quantity demand will be less, and at lower prices, the quantity demand will be more. We know that. But for many products, the demand line is a little bit more complicated than that. And one of the things we do to figure out exactly how consumers will respond to different changes in price, we use a concept known as elasticity. Okay? And there are some problems in the book that you're going to have to do this week that ask you to calculate elasticity of demand, and that's kind of what we're going to talk about here today, and what you do with it. So, let's take a look, first of all, at the information I have here on the board here. It's a very simple demand schedule for product X, whatever it may be. Let's assume for this particular example that we're looking at the demand schedule for a case of micro-brewed beer. Okay? So let's say I own this cool microbrewery, and at various prices, here's how many cases I sell a week. If I have the price of $10 for my super cool microbrew beer, I sell 500. If the price is 20, I will sell 300. If the price is 35, I'll sell 180. And at a whopping $50, I only sell 100 cases. Okay? So what does all this mean? Now, elasticity is rarely uniform. Okay? So what we're going to do is we're going to take a look at different elasticities at different price levels and see how it all works out. The first question you might be asked, and you may see this on an upcoming quiz or a question like it, it's going to say, what is the demand elasticity at one of the ranges? So let's take a look first at the $10 to $20 price range. Okay? So what is the responsiveness, again, of quantity demanded to this change in price? And there are a number of formulas you can use to do that. We will use what's called the midpoint formula. And in essence, really what elasticity represents is the percentage change in quantity over the percentage change in price equals elasticity of demand. So how do you calculate that? Your textbook shows you the formula, and here's how the formula will play out in our example. We're going to start with the change in quantity. So we went from $10 to $20, we went from selling 500 to 300, right? And to use the midpoint formula, now we'll have to take both quantities, 500 plus 300, divided by 2. This will give us the percentage change in quantity, all divided by the percentage change in price. So the price went from 20 to 10, 20 minus 10. You can use 10 minus 20. It won't matter for our intents and purposes because we're going to use the absolute value of our answer. Okay? I just want to know whether it is 1 or less than 1 to determine whether demand is elastic or inelastic. So the negative sign is not something we need to care about at this point in time. So 20 to 10, that's the change in price, over 20 plus 10 divided by 2. Okay? So when we do that, 500 minus 300 is 200. 500 plus 300 is 800, divided by 2 is 400, right? All divided by 20 minus 10, which is 10, all over 20 plus 10, which is 30, divided by 2, which is 15. So, to further simplify this, 200 divided by 400 is 0.5. 10 divided by 15 is 0.666 infinity. And when you divide those out like that, you are going to wind up with, I believe, about 0.7, let's see if I did it right, and I did, about 0.75. Okay? So in this range, between the $10 and $20 price range, elasticity of demand is 0.75. Thus, slightly or moderately, I would say, inelastic. Okay? So you have determined elasticity. Let's try another. Let's try it again. Let's take a look at elasticity in the $35 to $20 range. Okay? So in this range, it was 0.75, right? Okay? So again, we can do the same thing. We have change in quantity over change in price. So we have 35, quantity. We have change in quantity, which is going to be 300 minus 180, right? 300 minus 180 over 300 plus 180 divided by 2, right? Over the change in price, which is 35 minus 20 all over 35 plus 20 divided by 2. So, let me reach out here and get my handy dandy calculator so I can do the math. 300 minus 180 is going to give me 120, I think, right? And 120, 380 plus, or 300 plus 180 is 40 divided by 2. It's 240, right? Okay? 35 minus 20 is 15. 35 plus 20 is 55. And 55 divided by 2 equals 27.5. Right? So, again, we'll simplify this formula here. That's 0.5. And 15 divided by 27.5 apparently equals roughly 0.55. So, 0.5 divided by 0.55 equals roughly 0.91. Okay? So in this case, we still have, now we've moved from moderately inelastic to slightly inelastic. And again, just for practice, let's try it at the next level. In fact, a good idea might be to pause it right now and try it on your own. What is the elasticity between the $50 and $35 range? Okay? So you go ahead and pause the video now and try it on your own. And then when you're done, you can turn it back on again. We'll see how you did. Okay? Great. Well, welcome back now, assuming you've done the math. Here's what you should have done. Again, change in quantity over change in price if we move from $50 to $35. Okay? So we do the change in quantity first. It's 180 minus 100 over 180 plus 100 divided by 2. Okay? That's going to be the change in quantity. The change in price will be 50 minus 35 all over 50 plus 35 divided by 2. Okay? So this is going to be 80 over, let's see, 280 divided by 2, of course, is 140. All over 15 divided by, let's see, that's going to be 85 divided by 2, which is 42.5. So, 80 divided by 140 equals 0.57, right? And then 15 divided by 42.5 equals 0.35, roughly. So now I got 0.57 divided by 0.35, and here I get an elasticity of 1.63. So, once I've moved the price up this high, I have moved from a relatively, moderately inelastic in this range, slightly inelastic at this price range, and elastic at this price range. Okay? So I have calculated elasticity now for each of these price ranges. All right? Now, having done that, there is some information you can use for this sort of stuff. Okay? Let's say, for example, you get asked the following question. What do you do with this information? And let's say it says, assume that the price, elasticity between $35 and $50 is 1.3. It's not. We already calculated it. For the sake of this example out of the book, we'll just assume it's 1.3. What they want to know is what would happen, by how much would the quantity demanded change if there was a change in price, okay? Specifically, if there was an increase in price of 9%, okay? So this is really easy to calculate because the midpoint formula will work out real well because we have two of the three pieces. If you're given elasticity of demand, and you were in this example, it's 1.3. 1.3 will equal the change in quantity, which I don't know, that's what I'm asking, and versus a change in price. And you just told me price changed by 9%, or 0.09. Okay? In order to solve this pretty simple problem, algebraically, I'll just multiply both sides by 0.09. So 0.09 times 1.3 equals 0.117. These cancel out. And then to make it a percentage, I simply move it to decimal places. So, if you were a business owner, and and you knew the elasticity of demand in a particular price range, and you said, hey, I want to I want to increase prices or decrease prices. If I want to increase prices by 9%, I'm going to tell you right now, the quantity demanded will change by a corresponding 11.7%. Okay? The other thing you may be asked is, how does this kind of information impact us when we're trying to calculate something called total revenue? Okay? To calculate total revenue, let's take a look. Let's say, how is total revenue going to be impacted if I decrease the price from $35 to $20? If the price drops from $35 to $20, what's the impact on total revenue? Okay? That would be a relatively important piece of information to know. There's two ways you can calculate it. One, you would begin by calculating the elasticity of demand. Knowing that when demand is inelastic, okay, a decrease in price decreases revenue. Okay? When demand is inelastic, an increase in price increases total revenue. Okay? And we've already calculated the elasticity for this price range, right? Let's do it one more time just to make sure we're comfortable with it. So again, it is the change in quantity over the change in price. So the change in quantity from 35 to 20, we look 300, 180, 300 plus 180 over 2, okay? And the change in price, 35 to 20 over 35 plus 20 divided by 2. So once again, I reach for my handy-dandy calculator, as you should too. So 300 minus 180 is 120 over 240 divided by 15 over, once again, 55 divided by 2, 27.5. So it's 0.5, 15 over 0.5 over 0.55. 0.5 divided by 0.55 says roughly 0.91. So elasticity at this price range is slightly inelastic. Once again, we now know that if elasticity of demand is inelastic, decreasing the price will decrease revenue. Okay? That's one way to do it. Another way to do it is to simply calculate it out. So if you have $35 and you sell 180, and at $20 you sell 300, you just multiply it out. And clearly the math is pretty straightforward here. So at $35, this represented our total revenue, $6,300, and at $20, $6,000 was our total revenue. So either way, we know that A drop in price, if we drop the price of our beer from $35 to $20 a case, total revenue will go down. Okay? And that's some of the ways in which you can use elasticity and understanding elasticity to make business-based decisions. Again, some of the key things to remember: midpoint formula is pretty straightforward. Just plug in what you need to do to solve the equations. And once you have calculated elasticity, elasticity of 1 is basically referred to as unit elasticity. Elasticity of greater than 1.0 indicates increasing elasticity. That is, it is more responsive. And if you decrease price in that range, you will increase total revenue. If demand is below 1.0, demand is inelastic. If you increase price there, you will increase revenue. If you decrease price, you decrease total revenue. Okay? So those are some helpful tips. This will also be real useful to practice. There's some problems in the textbook that will allow you an opportunity to practice these, so go ahead and do that. If you run into any issues or problems, feel free to message me or email me, and I'll be happy to walk you through it. And then we'll go over the problems next week in class on elasticity. I hope you found this helpful. Once again, pretty straightforward concept. We're going to use this formula pretty much exclusively for calculating elasticity. So I hope you found that helpful, and I look forward to seeing you next week. Thank you once again for tuning into my video, and I will talk to you again soon. Bye-bye.